Hello and welcome to your strings lecture. So we've talked a little bit about strings as a type, but let's learn a little bit more. Strings are basically the way that a computer represents anything that's not code, but maybe has a bunch of words and is like language. For instance, we could have the string, "Hey, how are you?" And a computer could read that as strings because we have quotations around them. Now, we already ran over this in the types lecture, but let's go to Atom and check out how we can create strings. Okay, so we learned previously that there's three main ways that we can create strings. We can use single quotes, we can use quotation marks the way we're used to them, and we can use three single quotes to start and end a string if it needs to have multiple lines. Let's go ahead and create three strings using those methods. I'll go ahead and say S1 equals hello. S2, we'll use our actual quotations now, equals hello. And finally, S3 equals 1, 2, 3, hello. Beautiful. So we're going to print those out, S1, S2, there we go, S3. And all of these are valid ways of creating strings. We talked a little bit in the previous lectures about what the benefits are of using different ones of these. The only one that I think is really important to mention is when you use these three quotes to open and close a string, you can actually have multiple lines inside your string, and that's totally valid. That's not possible with the other two ways. I'm going to put that back, and then let's run our code. All right, so we'll say Python 3, and then the name of our file, strings 8 blank. Beautiful. All right, so you can see that all of our strings look identical when we print them, and that's because they're pretty much the same. The only difference is how we created them. Now, we've talked about whitespace in the context of code. For instance, we have indentation under a while loop or an if statement that tells Python what code to run in those cases. But whitespace can also appear in strings. Whitespace is things like a new line, a tab, or a space where there's no character that's necessarily showing up, but it's a part of your string nonetheless. So there's special characters that allow us to put whitespace in our strings, even those that aren't made with the triple quotes. So let's have a string called whitespace and set it equal to hey, and then we're going to put this backslash and an n. When you put these two things together, it tells Python that you want to add an enter or a new line. So we're going to say hey, add a new line, then say hi, add a new line, and then say hello, and add another new line, and then say ... Maybe this looks like some DMs that you get from bots where they just keep saying hi until you respond or block them. And now let's print out this string to see how it looks in our console when we actually run it. So we'll say print whitespace, and let's comment out all of these. All right, let's go ahead and run. Beautiful. So you can see that every time we had one of those backslash n's, it added the whitespace, in this case an enter or a new line for us. We can also do this with tabs. So let's say whitespace 2, and we'll say equals to big backslash t, which is for tab, stretch, there we go. And when we go ahead and print this, print whitespace 2, we expect to see some white space in our string, even though what we put was this backslash t. All right, let's go ahead and print. And again, we can see our hey, hi, hello, but also we can see big, tab, and stretch. Now, the reason I didn't go over spaces is because we've been using those all along, but spaces also count as white space in the string. So when we first started talking about different types in Python, we noted that there are a bunch of types that are collections, and strings are one of those collections. In this case, a string is a collection of multiple different characters all put together in one object, the string. And because of this, we can actually access individual parts of that collection one at a time. If we have a string, for instance, something like hello world, we can grab a single character from that string by telling Python the name of that string, square brackets, and then the index of what we want to grab. Indices in Python start with 0 and then increment up. So if we wanted to grab the h in hello world, we would say the name of the string, bracket 0. that would grab us the single character H, which is at index 0. And you can see all the indices up here. For instance, if we wanted to grab the capital W in hello world, we could say the name of the string, bracket 6. While less common, we can actually also grab characters based on where it's located compared to the end of the string. For instance, if we wanted the last character in a string, we could say the name of the string and -1. In this case, with hello world exclamation point, that would grab us the exclamation point. Let's head to Atom to try this out. All right, so let's start out with the string. My string equals hello mother, hello father. And now let's grab the first character from this string. Remember, indexing in Python starts with 0. So if we want the H in hello, we would say my string square brackets 0. Let's see what that prints out. All right, and as we expected, it prints out the H from hello at the beginning of this string. We can also grab other characters. For instance, we could say print my string 10. This will grab us the character at the index 10. And let's go ahead and run that. So in our case, it's E. Now remember, when you're counting through the indices, as we saw in the table in the slides, spaces and new lines and etc. also count as characters. So make sure if you're counting through them, you're still counting white space as a character when you're indexing. So for instance, it'd be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's why we got the E for mother as the item at the 10th index. All right, let's try one or two more. We'll say my string 2 equals my name is Chelsea. And for instance, we can say print my string 2 bracket 5. And when we run this, we of course get the M from name because 0, 1, 2, 3, 4, 5. M is at index 5. Last but not least, let's say HW equals hello world, just like we had in this slide. And we can say print HW 4, and when we run that, we get the item at the 4th index, so that'd be 0, 1, 2, 3, 4, and as expected, we did get O. Remember, we can also start indexing from the other end of the string, so if we wanted the exclamation point, we could say HW, -1, and we would indeed get the -1 or the last item in that string. Now we've grabbed single characters, but we can actually do something called string slicing, which allows us to grab ranges of characters from a string. For instance, maybe I want to grab world from hello world. The way that we do this is similar to grabbing a single character, except we give it 2 arguments now. We give it the index we want to begin with, and then the item that we want to go up until. That's a little confusing, so let me say that again. The first argument is similar to with a single character, the index where we want to begin slicing our string. So for instance, if we wanted world, the index that we would give it first is 6 because we want to start at index 6. The second index, however, is where we want to end, but it's up to but not including this index. So if we wanted the entire word world, we would have to say start at index 6 and end with 11 because it won't include index 11. It'll just include everything up until that. Let's go to Atom and check this out. All right, so let's try something simple first. Say that I want to grab the word hello from my string. I would say print my string bracket. Now where do I want to start? I want to start at index 0. Next, I have to tell it the index I want it to go up to, but not including. So 0, 1, 2, 3, 4, 5. I don't want to include this space, but I'm going to say index 5 because this will include all of the indices up to, but not including 5, which will be 0, 1, 2, 3, 4. Let's go ahead and comment this out and then see if we're correct. All right. Let's run that, and indeed we have just hello printed out to our screen. Now let's say from my string 2 that we'd like to grab just the name Chelsea. Well, we can say print my string 2 square brackets, And then we have to tell it where we'd like it to start. Well, if I just want my name, then I say 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. C is at index 12, so we will start at index 12. And then we can say what we want to go up to. In this case, we want to go all the way to the end of the string. And actually, the nice thing is that Python assumes you want to go to the end of the string if you leave the second argument blank. So if we say 12 colon and then nothing, the default is that we would go to the end of the string. Let's go ahead and print that out. All right, so you can see, just as we imagined, we got Chelsea from the string my string 2, by indicating where we wanted to start, and then by leaving the second option blank, indicating to Python that we want to go with the default option, which is to continue till the end of the string. Now, let's talk a little bit more about default. So we'll say print my string 2. Now, we have so far only given Python 2 arguments when string slicing. We've given it the first argument, which tells us what index to start at, and we've given it the second one, which tells us where to end, or at least what to go up to, but not including. If we gave it just nothing, this would return to us the entire string. The default for the second option is go to the end of the string. If we don't specify, the default for the first option is start at the very beginning of the string. So let's go ahead and print this out. Beautiful. You can see that when we gave the default argument for both of them, it printed out the entire string. It started by default at the beginning and ended by default at the end. All right, I've been hiding something from you. There's actually a third argument that we can give when string slicing. For instance, let's say we wanted to see our string backwards. We could do that by saying -1 as that third argument. And when we run our code, you can see that indeed it prints out our string completely backwards. This final argument tells Python how to move through the string. A negative number means we're going from the back end to the front. A positive number means we're going from the front to the back, as per usual. You can see that when we run this, we indeed print out our string entirely backwards. The default for this argument is 1, which means go forward and hit every single character along the way, not skipping any. However, we can also specify that we would like to skip some. For instance, let's from this string only grab every other letter. In order to do that, we're going to have 2 in this place. Let's go ahead and run that. Awesome. So now our string is going from beginning to end. However, we're skipping every single other character. For instance, we get the M, not the Y, get the space, not the N, get the A, not the M, get the E, etc., all the way through this string. Now, just to review, if you were to leave all of these arguments blank, the default for the first argument is begin at the beginning of the string, the default for the second argument is end at the end of the string, and the default for the third one is 1. In other words, go through the string from left to right and make sure you don't skip any characters. Using this, we can do some pretty weird things. For instance, print HW, and we'll say default -2. Let's see what prints out. Awesome, so you can see when we give it -2 for that hello world string, it goes from the back end to the front end of the string. It's going backwards and it's skipping every other character, which is how we end up with this weird string, low space lay. All right, let's talk about string operations. Now, we learned about operations on integers or other numeric types, but we can also use some of them on strings. Let's start with addition. In addition, with integers, we can add 2 integers together and we get the sum, basically what we would expect mathematically from that operation. But what would it look like to add 2 strings together? Let's go to Atom and find out. All right, just to review what we've learned before, let's go ahead and print out what 1 + 1 with both of these being integers is. As we expected, it's 2. Now let's say print 1 + 1, but let's make both of these strings. So say 1 + 1. Now take a second to think a little bit about what you think the results of this addition will be. Remember, these aren't numbers, they're strings. So what do we think is going to happen when we add them together? All right, hopefully you've paused, thought about it a little bit. Let's see what the answer is. So let's run this. Interesting. So we actually get a string that is just our two strings concatenated or basically glued together. That's what addition does for two strings. It basically just glues them together. We could also do this with two strings that aren't numbers. For instance, print my name is plus Chelsea. And when we run this, you can see that it'll output my name is Chelsea. Notice that we had to add a space here because when we add two strings together, it directly glues them together. It does not add any spaces or anything like that automatically. Now that we've seen addition, let's talk about multiplication. With integers, or in math class, if we multiplied 1 times 10, we're taking 1 and adding it to itself 10 times. The result, of course, will be 10. Let's go ahead and make sure that's true. Comment that out and run our code. And again, we get 10. Very expected. Now, remember that in math, multiplication is just addition done a bunch of times in a row. So with that in mind, take a second and think, what do you think is going to happen if I did this, the string 1 times 10? Based on what you know about what addition is with strings, what do you think multiplication is going to look like? And what will the result be of multiplying the string 1 times 10? Okay, hopefully you've thought through this. Let's go ahead and run it. Okay, so you can see that the output here is 10 ones, all glued together. For strings, we also have concatenation with multiplication. We just do it multiple times in a row. So if you have a string and multiply it by an integer, it's going to glue that string to itself that many number of times. For instance, I could say print ha times 10, and when I run this, you can see it prints ha 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 10 times. All right, now that we've talked about operators that we've seen before, like addition and multiplication, let's talk about a new one that can help us specifically with strings. That's the in operator. The in operator is useful, as the name implies, for helping us check if a substring is inside a bigger string. Remember that a string is a collection. It is multiple characters all mushed together. This can help us, for instance, check if a single character is inside of a collection of characters, another string. Say we have that this variable called vowels and set it equal to A, E, I, O, U, which is of course all of the lowercase vowels. We can use the in operator to check if a single character is a vowel by saying, is this string inside the bigger string A, E, I, O, U? This, for instance, will output to be true because the lowercase a is inside the string A, E, I, O, U. We can also check, for instance, if X is in vowels, and we know that X is not a vowel, and it's indeed not in this string, so when we say X in vowels, it will evaluate to false. Now, remember, when we say something in a string, we're checking if that something, a smaller string, is in the bigger string. And we're specifically looking for those characters in that specific order. For instance, if we checked is A, E, O in vowels, well, A is in it, E is in it, and O is in it, but the combined string A, E, O is not in the bigger string of vowels, which is A, E, I, O, U. So this statement would evaluate to false. Let's go to Atom and check out some other examples. All right, let's have a string called name and put in Chelsea. So for instance, we can check which letters are in my name. We could say print E in name. And when we run that code, this will print true if there's a lowercase e in my name and false otherwise. Let's go ahead and run that. Beautiful. So this evaluated to true because there is indeed one, actually there's two lowercase e's inside the string Chelsea. Next, we can say print J in name. This is going to check whether there's an uppercase J in the name Chelsea, and let's see what Python has to say. It says false, which makes sense as there is no uppercase J in Chelsea. Now remember that in Python, case really matters. So if we said print lowercase c in name, Now, there is a C in Chelsea, but it's a lowercase c here and an uppercase in the string. So let's go ahead and see whether Python thinks C is in name. We go ahead and run that, and that says false. Even though there's an uppercase c, remember that those are very different things in Python. There is no lowercase c, so C in name evaluates to false. We can also check whether longer substrings are part of a bigger string. For instance, I can say print. This will check if this specific substring in this order is in the bigger string. In this case, it should be true because CHELS is indeed a part of the substring Chelsea. So let's go ahead and run this, and Python agrees with us. Chels is a substring of Chelsea. Last, I'd like to talk about immutability. This will make a little more sense when we talk about mutability versus immutability in different types that we're talking about, but I want to talk a little bit about the immutability of strings. Strings are immutable. That means once we create a string, we can't change individual characters within that string. For instance, if we had the string hello, we couldn't grab the first character and try and change it to J in order for it to be Jello. Let's go to Atom and see what happens when we try and do this. All right, so now we have the string hello, and as we saw in the slides, let's print x bracket 0. As we learned about from string slicing, this should grab us the first character, the character at index 0 from our string. When we run it, that's indeed exactly what it does. And I'm going to go ahead and comment out this so that we're not getting extra output. So if we can access the first character of the string, it might make sense to us that we could try and change just that character. For instance, trying to do Jello instead of hello. Let's go ahead and try that out. So we would say x bracket 0 equals J. This would basically be telling Python, okay, take the first character, change it into a lowercase j. Let's see what happens when we try and run this. Awesome. Okay, we get a type error. This is basically indicating to us that strings are immutable. We can't try and change a single element of the string. We would actually have to create an entire another string because once strings are created, they're immutable. You can't change parts of them. You can only get rid of that string and have an entirely new one. So if we wanted x to be equal to Jello, instead of changing an individual character in our already made string, we'd have to just create an entirely new string. For instance, we could say x equals Jello. In this case, instead of trying to change the string we already created, we're just creating an entirely new string and reassigning it to the variable x. Let's comment this out, and then we'll print x and go ahead and run our code. Cool, so you can see x is now equal to Jello, but we couldn't do that by changing just one character. We had to create an entire new string because, again, strings are immutable. Once we create them, we can't just change part of them. We have to create an entire new string if we would like to. All right, that is all I have for you. I will see you next time.